Thanks, Derek, for that introduction. Good morning, everyone. I would like to start just with an introduction of NX Filtration. We will go over to our application areas and then also our product portfolio. We'll touch on UF retrofits and reuse projects. So first of all, NX was originally started as a nanofiltration company in 2016, where our founder he produced membranes from the University of Twente, located in Enschede in the Netherlands. We are also based in the Netherlands in Hengelo. That's where we've got a factory. We say it's a world-class factory. We can produce up to 60,000 modules per year in this factory, with the possibility to scale up further to 120,000 modules. So that makes us the largest hollow fiber factory in the world. Our products is all hollow fiber membranes, so that ranges from nanofiltration to ultrafiltration and also microfiltration. We distribute our products through 5 regional sales offices globally, and since 2021 we've launched more than 400 projects. We are an ESG driven company, so we are fueled by innovation. And maybe just to mention, within our factory we treat the water that we use to manufacture our membranes with water from a nearby canal. This water is abstracted from the canal, directly treated by our nanofiltration membranes, followed by reverse osmosis, and then used to manufacture our membranes. So it's well known that water scarcity is not only in South Africa, but globally. And we see that climate change is actually, it's helping, well, not helping, but contributing to the groundwater sources being exhausted. So, taking that into account, about 60% of the world's population currently lives in water scarce areas, and that leaves 2 out of 7 people without access to clean drinking water. So, that being said, there is a need for alternative sources to be used instead of just groundwater. But these sources are usually polluted with micropollutants and medicinal waste. Just taking, for instance, the wastewater that we produce from normal domestic sewage, that is being treated conventionally, and that conventional treatment is not equipped to remove medicinal waste, for instance. And that effluent is just discharged into our rivers, where we then abstract water for drinking water, using again conventional systems which do not remove these micropollutants. So with that being said, there's a need for alternative technologies, new technologies. And with NX Filtration's nanofiltration membranes, we can remove some of those micropollutants without the need for chemical use, so applying that water almost directly to the membranes. So going into application areas and the product portfolio. So as I've mentioned, we have nanofiltration, ultrafiltration, and microfiltration membranes. All of these membranes are hollow fiber. The nanofiltration range, we have 2 products, the DNF80 and the DNF40. And that is, the 40 is a 400 Dalton cutoff, while the 80 is an 800 Dalton cutoff. And these membranes were specifically manufactured developed to remove organics like your CODs and also micro from the water. And this is basically without chemical dosing, so you don't need your coagulants and flocculants. So almost a one step. Our ultrafiltration range ranges between 10 and 150 kilodalton, and this is mostly for your, like for instance, RO pretreatment or wastewater treatments, and that is mostly for your virus and bacteria removal. Microfiltration is mostly used in the food and beverage industry, and our membranes are applied to clarify beer and wine. Okay, so first of all, I'll focus on the nanofiltration range, and we've seen in many cases that a traditional process, including coagulation, flocculation, your sand filtration, UF and RO, with usually a remineralization process afterwards, can be condensed into a simpler treatment step. Whoops, sorry, it's automated. So taking, for instance, a simple pre-treatment like a strainer or in some cases a sand filter, and applying that filtrate to a hollow fiber nanofiltration system with a post-treatment can give you the same water quality or even better. So the nanofiltration technology is a patented technology. So in the first picture you see, it is a single fiber with the patented layer-by-layer technology. And this is a charge-based membrane. So the layers would be, the layer that is subject to the water quality would be negatively charged at pH of 7. So the second picture is what a module would look like from the top. So that's all of these fibers connected, installed in a module. And then the third picture is the vertical installation of a membrane system with the nanofiltration modules. Also, just to mention, our membranes, the membrane modules do have some drinking water certification. So NSF, QR, and ACS. And then, so if we would compare traditional nanofiltration to our hollow fiber nanofiltration membranes, what is the difference? So we claim that our membranes can basically take on more worse feed water quality. So that would be an increased turbidity, suspended solids, which we take around peaks of 300 ppm, and also CODs ranging from 100 to 1000 ppm. Our membranes are chlorine resistant, so they can take chlorine up to 250 ppm hours at elevated pHs above 10. These membranes are also backwashable, so in many cases you would need quite extensive pre-treatment with your spiral wound nanofiltration membranes, which is not necessarily necessary for the hollow fiber membranes. Two key applications for our nanofiltration membranes is surface water treatment and also wastewater reuse. So on the surface water treatment side, we do apply our membranes for drinking water. That would be, for instance, on a river to remove your organics, color from the water, and some micropollutants. And that water can then be used for drinking water, or also in industrial processes, dependent on the permeate requirements. On the wastewater reuse side, we also we can do municipal wastewater. That's one of the sweet spots for our membranes. So after clarification, after the clarifiers, with a drum screen, and then followed by the nanofiltration membranes. The permeate then can be reused or even further treated for potable reuse. But I'll say more about that later after the tea break. On the industrial side, we've seen also, so for instance, pulp and paper, any wastewater that has been treated biologically can also be applied to the membranes relatively easy. So in both cases, the main parameters that would be removed is your organics, COD, BOD, color, and also some suspended solids, turbidity, and then your PFAS and micropollutants. So globally, we do have an installed base of nanofiltration membranes, mostly in the European region where we are based. But this slide is just to indicate to you that we do also have installations in other countries in the world, also in Asia, Indonesia, Australia, and also Northern America. Then just bringing up the slide again to highlight the ultrafiltration range. Like I've mentioned, smaller particles, 10 kilodalton to 150 kilodalton. The more tight membrane, the 10 kilodalton, is used mostly for silica removal, while the UF10 is the membrane that's usually used in for RO pretreatment, for instance. Our filtration principles also applies mostly for the nanofiltration. All our membranes are PES based. They are single bore and inside out. So that being said, with the PES membranes, should you use our membranes, you could be covered for future regulations where PFAS could become an issue. On the ultrafiltration side, main applications would be potable water, municipal wastewater reuse again, and reverse osmosis pretreatment. That's where we mostly apply our ultrafiltration membranes, and then also in industrial wastewater reuse. We've got a global base of ultrafiltration membranes, which might be something new to you because we are a nanofiltration company, right? So yeah, I will cover a little bit later that we also have a few replacement products available for the membranes that's currently in the market. So good performance declarations directly from our customers. Also something to show that we have real world validations of how our technology is performing, which is important for us and I believe also for our customers. And these declarations just confirm that our technology is reliable and also robust. I just wanted to mention that we do have confirmation directly from our customers that our membranes are performing. So just an overview of where we apply our ultrafiltration membranes. Oops, sorry, this one is automated, so I hope it will stay here now. But water reuse in a poultry processing plant in Central Europe. So our membranes are applied after a sand filter, just before reverse osmosis, and I believe this water is then being reused in the factory again. Here we use our WMC200 UF 150, so 150 kilodalton membranes. There's 4 skids, 40 modules per skid, and the membranes have been operating for more than 6 years. So fluxes of 40 to 50 LMH has been reached. RO pretreatment, so seawater desalination. This is in Saudi Arabia. So at the port of Jeddah in Saudi, we have a customer, Kandasa Water Services, that was also one of the good performance declarations which I've shown earlier. And this is to treat the seawater from the Red Sea. There we've got 880 modules installed, and that's the HydroCap 60, which you might be familiar with from the hydronautics range. So system configuration, again, 10 skids, 88 modules, and our first replacement was in 2021. High recoveries of 90 to 92%, and this is also just before reverse osmosis, more than 4 years. Then a seawater desalination plant again in India. So, also 30 skids, 120 modules, and here we've got one of our most recent developments of ultrafiltration membranes installed, 55 square meters, and that's also UF 150. We're operating at fluxes of 80 LMH and reaching an SDI of less than 1. So again, lamella clarifier, disc filters, ultrafiltration, and then reverse osmosis. So like I've mentioned, we can replace our membranes cost effectively with one-on-one replacement. It's a technical fit with most of the membranes that's currently in the market, and our membranes can fit GE, Penta, DuPont, Inga, Hydronautics, and also VWS. So we do, in cases where we do need adapters, we do have those available. So we can do a retrofit, or we can assist with a retrofit to your needs. Our membranes can be, all of our membranes are backwashable, and the normal CIP and cleaning ways are acceptable. And then just to give an overview of all our water membranes, so it's including the nanofiltration here and the ultrafiltration. So the two modules on the left-hand side of the screen is your nanofiltration, and all to the right is your ultrafiltration membranes. So there you can see that the ultrafiltration also goes from anything from 15 square meters up to our latest development, 65 meters squared. So yeah, I believe if you would like to discuss any replacement projects or so, I'm more than happy to discuss that further. And then should you want to develop a membrane project with NX filtration, we do application feasibility checks within our sales engineering team. Also, we have our own in-house projection software, so we usually assist with that also. We do assist with full-scale system design, so should you need any information from us or need assistance with checking PNIDs, we do have those we do have those expertise within our team. And then we can also assist with startup and commissioning of your plants. So just to recap, I mentioned a little bit the unique features of HFNF and the main application areas, which is your surface water and wastewater treatment, as well as UF applications and retrofitting capabilities, our membrane portfolio, and how you can develop your project along with us. I think in the end, we've all got one mission, and that is our motto at NX Filtration, is clean and affordable water for all. So, thank you.
Issues with PFAS may not have a problem. What do you mean by that? And what membrane material? I'm assuming it's something to do with the manufacture and the material of the membrane itself. That's when it's not PS. But yeah, maybe you can just talk about that statement a little bit.
Yeah, thanks for the question, Rob. So basically the PVDF manufacturing of PVDF membranes would become a regulation eventually, where PVDF would fall under that under the PFAS regulations or the micropollutant regulations, and that is where we are already covered. And from a manufacturing point of view, to be all right with continuing our manufacturing.
So does that mean that people making PVDF membranes? I mean, it's kind of bizarre. You're making membranes to treat water that are causing a PFAS problem. Is the PVDF manufacturing is using PFAS material? Is that what?
Yeah, that is it.
I didn't know this. I learned something today. Okay, thank you.
Thanks, Rob.
You mentioned that you don't require chemicals for the process, but with nanofiltration systems, you generally do find that there is a scale challenge. So I'm wondering how this system is managing that challenge.
Yeah, thank you. So in some cases, we do see that there is that there would be an anti-scalant requirement, and then we would recommend an anti-scalant. Oh, well, we wouldn't recommend the anti-scalant, but we would recommend the customer to use an anti-scalant. But in most cases where we see that there's no anti-scalant or that there's no scaling, no scaling warnings coming up in our projections, we would be comfortable with running without an anti-scalant.
And on the PFAS side, PFAS is a very broad kind of term because it covers an awful lot of different substances. How selective is 100% all PFAS is rejected, or there is some passage depending on the species?
No, so in some cases, we would for PFAS we would recommend our more tighter membrane, which is the DNF40, and that would remove up to 80% of your PFAS. So in some cases, you would need a second step to do polishing. And usually what we see then is, say for instance, you do GAC. Your GAC might just last a bit longer also on the operational side.
Okay, I have one last question, if that's okay. Is there any tendency for PFAS to accumulate in the membrane itself and make the membrane also a requirement for disposal as a result of PFAS accumulation?
Not as far as I know, but as far as I know, it would all end up in your concentrate.
Thank you.
Thank you.
Yeah, thank you for the interesting presentation. My name is Bonginkosi Nyemba. I'm from ESCOM. So I'm more interested on the stats you shared earlier on. You mentioned that only 2% of wastewater is actually reused in Europe. I mean, why is that the case? Because I thought we were encouraging wastewater treatment and reuse.
As far as I know, I don't know why that is specifically the case. I think we've got enough water so far still in Europe to not having to look at wastewater reuse. But yeah, that's as far as I know.
So I think in South Africa, we can teach Europe quite a lot about wastewater reuse because we do that a lot. Thank you.
I agree.
Thank you so much. I just wanted to make up a follow-up question from the good Mr. there. So when we talk about PFASs, do you have any idea of how many you have actually investigated so far? Because I think most of the time when we talk about PFASs, we look mainly into the likes of PFOA and PFOS as well as PFBA, while in an actual sense, given the extensive list of PFASs that we have, we tend to ignore the other ones which actually have been reported to cause the same effects and all that. So do you have any idea of the list that you have tested for?
We do have some studies where that information is available, so perhaps we can share that information with you.
Okay.
But I do not have that on hand at the moment. Sorry.
All right. Thank you.
Thank you.